Hello guys, I'm back with another video. In this video, I'm going to show you how I created a custom transport protocol using C. This protocol sends data via serial virtual ports using Termios and Socat. So before getting into the video guys, I want to show you something. This is the GitHub organization that we are having, so it contains all the source code for the repo, for example, the shell that we have created and everything. I will drop a link below, please check it out guys. So this is the custom transport protocols repo. So it is a serial data link transport protocol using Termios and virtual UARTs, and CTP, it's a frame-based transport protocol, so it uses frames for transferring data. So these are the features included in CTP. Firstly, the frame structure. So each of the frames that I've created will contain a preamble, sequence number, acknowledgement number, the data, and the cycle redundancy check, error detection code, error detection number. And the second thing is CRC error detection. So it basically detects whether there is an error in the data that is being transmitted, and if there is an error, it will again send the sequence number to the sender side to transmit the data again. And we are also having acknowledgement flag for the sender to know that the data has been received. And we are having a virtual serial communication. I didn't create the protocol, but also I want to bring it to life, so that's why I used virtual serial communication to create virtual ports to get to know how the protocol is really working. And we are also having Termios integration. Termios is nothing but you can set the bit rate and the baud rate. For example, here I set up 9600 baud rate and everything, and the blocking mode. And yeah, of course, it's a simple data transfer mechanism. So that's all about the features. This is the architecture of the custom transport protocol. Here we are having the frame structure, and we are having the CRC check for both the sender and the receiver. So they are going to send the data to the Termios ports, Termios file descriptors. I will elaborate that in the next. So, and then it will send the data to the ports in the socket, socket cat. So socket means socket cat. So yeah, in the ports 1 and port 2. So that's about the architecture. So let's get inside the block. So I know that just reading the code won't make sense. So I created a blog describing the entire architecture of the CDB protocol. Firstly, we are having frames, the error checking mechanisms, and sequencing and acknowledgement number and everything. So let's get inside the code. So yeah, here. So let me just first get inside the packet. So this is the packet structure, as I've said before. We are having a preamble, and the preamble that we are using is hexadecimal. It's 0xAA, and we are having the sequence number, acknowledgement number, and the data and the CRC bits. So this is the packet structure. And moving on, we are having, these are the things that I've been including. These are just the header files and the acknowledgement. I'm using send acknowledgement and wait for acknowledgement. So let's just get inside the source code for this. So firstly, the acknowledgement. So whenever the sender is sending the data to the receiver will send an acknowledgement packet stating that, hey, I received this frame from the sender with this sequence number, and the CRC bit, if it is 1, it means that there is no error in the frame that is sent by the sender, which is again received. So this receiver will send the acknowledgement pack to the sender, and the sender will wait for the acknowledgement packet, and once it is received, it will again check whether the CRC is 1 or 0, the success rate. And then if it is 1, it means that the packet is successfully sent to the receiver and the acknowledgement pack has been received. So the entire flow was done correctly, and there's no need for resetting the frame again. So this is the send acknowledgement function. So I'm setting the preamble 0xAA and sequence number is 0 for the acknowledgement packet. I'm not setting a number for the acknowledgement packet, for the acknowledgement sequence number, and I'm setting the acknowledgement number to be the same as the sequence number. And then for the acknowledgement package, packet or frame, we are not having any data inserted to it. It's just an empty frame. So I'm setting everything to 0, and the success rate for this is 1. So this send acknowledgement function will be used by the receiver. I will show you that later. And then we are sending the frame again to the file descriptor of the ports that has been opened. And this is the wait for acknowledgement function. It checks whether the acknowledgement number, which is set here, the sequence number of the frame that has been sent, which is same as the expected sequence number or not, and it will check the CRC to be 1 or not. If it is okay, then it will send the acknowledgement for the frame. So this is the part of the receiver, this is the part of the sender. So that's the thing about acknowledgement. And then we are having the send frame and receive frame. So send frame and receive frame are used for sending and receiving the frames from the file descriptors. So here we are having the file descriptors, which is set by the Termios, and here's the file descriptor for the receive frame. And we are firstly reading the first byte of the frame. If it is a preamble, that means that is a start of a new frame. And then we are copying the rest of the frame's data into the file descriptor. And then that's the receive frame. And send frame, we are writing the data which is sent by the client to the file descriptor. So that's data sent successfully. And then okay, let me go to the Termios one. So Termios is used for opening the ports. So Socat is used for creating the ports. We are going to be creating 2 ports, one for the sender and one for the receiver. The sender and receiver will communicate through these 2 ports. So Termios is used for opening that ports for the sender and receiver for communicating. It's also used for setting up the baud rates and the character size so that it matches both the sender and the receiver. So that's what Termios does. And here we have the CRC. So firstly, what is CRC is cyclic redundancy check. So this I firstly implemented checksum, but it only works for 1 bits or 2 bits. It fails for multiple bits if there's an error with multiple bits. So that's why I implemented CRC for this one. So in CRC, we are actually just we are actually just having a polynomial. We are converting the data into zeros and ones, which is the data polynomial, and we are having a fixed divisor polynomial, and then we are actually dividing it, dividing the dividend with the divisor, and we are going to get a reminder of those bits, and then we are adding those reminder bits with the data that has been sent by the sender. We are just adding it. And after it has been received by the receiver, the CRC check will be done again by the receiver. If we got 0, that means the CRC of the sender will be equal to that of the receiver. So that's the thing about CRC. So this is string to bits, and one thing that I wanted to say clear, guys, is that there is no C library that that converts directly the string to bits. So I created this function string to bits for converting the string message sent by the sender to 2 zeros and ones, so that it can be utilized by the CRC for converting and checking the errors. So that's the CRC part. I think the entire source is done, and then we are moving to the data link. So this is the main function that is going to be calling the sender and the receiver. Firstly, we are setting up Termios, and this is the port and the preamble and the message and everything, and then we are converting the string to bits, which is the message hi. And then we are computing the CRC, and inside the transmitted message we are going to be adding the reminder, which is done by the CRC, to the transmitted bits, and then we are going to send the frame. After sending the frame, we are going to wait for the acknowledgement, which is going to be sent by the receiver. And once the acknowledgement is received successfully, it's going to be saying that received acknowledgement successfully and sequentially incrementing the sequence number. So that's what sender does. Let's see what the receiver does. The receiver is going to check the message sent by the sender, again doing the CRC. If the CRC becomes 0, it means that there is no error in the sent message, and then we are going to get the CRC of the compute CRC that we have done. We are going to check whether the CRC of what we have done with the data that we received with the data that has been actually sent. If it is equal, we are going to send the acknowledgement flag saying success as 1. Here, this one will reflect in the ack.crc as 1. So whenever we get an acknowledgement package with 1 as the CRC number, we can safely say that there is no error in the acknowledgement package. And then the receiver sent ACK successfully. That's the thing about the entire coding of CTP. So let me just create the Socat ports here. So yes guys, we have created the ports. The link /tcp/sender, it means that we are creating a custom name for this port and the custom name for this port. Yes guys, let's run this code and see how it works. So let me just create the make files, and firstly we are going to run the receiver. The receiver is going to be waiting for the data, and then we are going to run the sender. Here guys, look at that. The sender sent the data successfully, and we are checking for the ACK, and the ACK for frame 1, we are sending only 1 frame, and the ACK has been received here and received here. So these are just bunch of messages on my terminal, but let me show you what it does here. So this is the receiver port. So we have to check whether the data is received or not, right? So let me just create a cat for this particular thing, and let me just run this again. So let me just run the server sender. Okay, sorry. So let me just run the receiver and then run the sender, and the data has been sent. And look at here guys, this is the received data. Hi, can you see here this bunch of gibberish things? These are just the frame that we are sending, the preamble, the sequence number, acknowledgement number, and everything. So that's it about the entire CTP guys. I hope you like this video. If you like this video, please like, share, and subscribe, and see you guys again with the next awesome video. Bye bye.